We are going to solve the system of equations that has a quadratic function and a linear function algebraically. So we're going to use substitution to do this. We start off by letting f at x equal g at x so that we can solve for the values of x that would satisfy this equation. So we're going to sub in on the left-hand side, negative 2x squared minus 5x plus 20 equals 6x minus 1. So there's the f at x, and there's the g at x. This has an x squared term in it, so we are going to either use the quadratic formula to solve for the x values, or a factor if we can factor. So first we'll gather all the like terms on one side to let it equal to 0 so that we can get this quadratic equation into standard form. So we'll do that. Negative 2x squared minus 5x minus 6x is going to give us minus 11x. And then plus 20 plus 1 is plus 21 equals 0. So we're going to try to factor first here. The product is negative 42 and the sum is negative 11. We can factor this equation. The two numbers are going to be negative 14 and positive 3. So since we have an a value that's not equal to 1, we're going to use decomposition to factor this. And when you use decomposition to do that, we're going to end up with the factors of x plus 7 and negative 2x plus 3. Now if you want to see factoring by decomposition, go to one of my other videos and see the steps on how we get from the standard form to this factored form using the decomposition. Now from this factored form, we can find our two x values to satisfy this equation will be x equals negative 7 and x equals positive 3 over 2. But these only give us the two x values that would solve the system of the two equations, so we need to find the corresponding y values for this. To do that, we're going to take each x value and sub it back into either one of these two equations that we were given, because we know that those x values would satisfy both equations. If I were you, I would always choose the easier looking equation, so I'm going to go with the linear equation here of 6x minus 1 to sub in my x values and solve for y. So let's go back here. Then if x is negative 7, the corresponding y value is going to be 6 times negative 7 minus 1, and this gives us a y value of negative 43. And if x is 3 over 2, you can use 1.5 if you feel more comfortable with the decimal. We sub in the x value and get 6 times 3 over 2 minus 1, and this gives us positive 8. And so the line and the parabola cross at two different points, and the first point of intersection will be negative 7, negative 43, here and here, and the second point of intersection will be 3 over 2 and 8. From here and here. So if we wanted to, we could do a check, take these x values and plug them into both equations, and we should get the corresponding y values if we've done it correctly.